Welcome again. We're getting towards the end of our advanced trigonometry unit now, and this latest Me vs Maths tutorial covers how we decide whether the sine rule or the cosine rule is suitable for answering a particular question. Please note that I'm not trying to teach you in this tutorial how to use either of these rules. We've separate tutorials for that, so the actual working out for each problem will be quite quick. If we make a quick comparison between the two, we can see just how similar they are, and hence why it can be so confusing knowing which to use. Both can be used in non-right angled triangles. Both can be used to find sides, just as both can be used to find angles. We don't seem to be getting so far to see how they are actually any different from each other, so let's try looking at the formulas that we use for the two rules. Firstly, remember we only ever use two parts of the sine rule at once, so let's ignore the last part for now. To use the sine rule, we need to know all of one part of this formula and one other thing, so we must know an angle and the side opposite. And if we know one other side or angle, we can find the one opposite that. For example, if we know side B and angle B, if we also know side A, we can find angle A. Whereas in the cosine rule, we're using all three sides and only ever one angle. So if we're looking for the angle, we have to know all three other sides, or if we're looking for a side, we need to know both the other sides and the angle opposite. So the key difference is in the combination of sides and angles we're given, and this last bullet point is what we must focus on. So to use the sine rule, we need to know a side and the opposing angle and something else. For the cosine rule, we need to know an angle and the two adjacent sides, or all three sides if we're trying to find an angle. So here we're being asked to find an angle. To be able to use the sine rule, we need to know a side and the opposing angle. Here we don't know any angle, so the sine rule is of no use to us. To use the cosine rule, one option is that we know all three sides. Here that's exactly what we know, so we can use the cosine rule. We're going to use x's, y's and z's rather than a's, b's and c's, so let's label up our sides first of all. As we're using different letters, we've rewritten the cosine rule to use the correct letters for our question. So all the a's have been replaced with y's, all the b's have been replaced with x's, and finally we've swapped z's for c's. Now substitute our values in and complete the question. We're going to do this very quickly, as I said earlier. We're looking for an angle, so as we know, we'll ultimately have to use the inverse cosine function to get a final solution of 80.7 degrees. And as I say, if you want to spend a bit more time looking at that working out there, then just pause the video for a moment. Okay, our next starting point. We're being asked again to find an angle. This time we do know an angle and the side opposite because we know angle R and side R, and we also know a side PR, and we're being asked for the angle opposite. So this is a case where we can use the sine rule rather than the cosine rule. Label up our sides. We'll use the PQR notation from the question. Therefore, we need to change the letters in the sine rule. Notice too that we're using the alternate form of the sine rule where the angles are on top, because we said this is the easier form to use when we're finding angles. And as before, we'll work this out really quickly, so feel free to pause if you want to study this solution in a bit more detail. We have to multiply by 0.6 to give us sine q, and then again use the inverse sine function to find our missing angle, which is actually 26 degrees. A new question, and here we're wanting to find a side. We do know a side and the angle opposite. the 13.8 centimetres and the 71 degrees. And we know another angle and we're looking for what's opposite that. So the sine rule will work again. Label up our sides, no need to swap any letters around for this question. We can use the A's, the B's and the C's. So it's a fairly standard sine rule question, and again, if you need more time to look at this solution, then just pause the tutorial here, but we're going to move straight on to our next problem. Here we're being asked to find a missing side length again. We need to know a side and an opposing angle to use the sine rule. So that's a no-go for this question, as we know the angle that's labelled as 97 degrees, but we don't know the side opposite. To use the cosine rule, we need to know an angle and the two adjacent sides, which is exactly what we know here. We know 97 and the two adjacent sides, that means the two sides next to that angle, which are 4.9 and 6.7. So it is definitely a cosine rule question. I think the cosine rule is a bit nasty to swap letters with, so if we don't have to, we want to avoid it. As we've only got one letter in our original question, let's relabel this triangle, instead making sure I use the angle that I know as angle A, and so on. Now we can use the cosine rule without any more changes. Let's substitute in all our given values then and solve this question. Remember to be particularly careful with all these steps, as it's so easy to make a mistake on the cosine rule, and eventually we arrive at our final answer of 8.8 metres. One final example for us to look at. We've used this as a final example because actually neither rule will allow us to find angle DFE, which is the one at the bottom right hand corner of the triangle, in one go. But we do have the information that we need to be able to use the sine rule, as we know a side and the angle opposite. So we can use that to actually find angle DEF, the one at the bottom left hand corner, first of all. So let's find angle DEF using the sine rule. As always, step 1, label our sides. We'll keep their letters, so we've swapped the letters in the sine rule that we're going to use. Once we've done that, we have a relatively straightforward sine rule question to solve for our angle, which we'll find to be 62.4 degrees. Now this wasn't the angle we were being asked to find. This is the angle that we were being asked to find in the bottom right hand corner. Now it's amazing on reaching this point how many students start trying to use the cosine rule or some incredibly complex method to find this missing angle, completely forgetting the simple fact that angles in a triangle always add up to 180 degrees. So now we know our other two angles, we just need to subtract these from 180 and we'll find our angle DFE, which is actually 75.6 degrees. Okay, all done. As I said at the very start, we did go through the working out very quickly in this tutorial, but hopefully we've achieved our aim of helping you to see the differences between the two rules and how you know when each should be used. The very final tutorial in our advanced trig section is on finding the area of a triangle using one final formula, half AB sine C. I hope you'll join me for that soon. As always, visit us at meversusmaths.com for lots more assistance to help you with your maths. Take care and bye for now.